problem given arrays of different type of denomination of coins and the target amount that it needs to get changed, uh, the total amount of money, and our goal is to give the fewest number of coins that makes up this target amount. And if it doesn't make up the target amount, then we will just return -1, and we can assume that we have an infinite number of each kind of coins in our use. So let's imagine that you're running a business and a customer came and gave you 11 for a change. Then your goal is to give the fewest coins possible, and what we are going to give is that we'll give 5 cent, 5 cent, and 1 cent, which will make 11 cents here. And I mean, there could be a lot of other ways of giving the amounts, like with 1 cent 11 times, or with 2 we could give I don't know, it's like 5 times and give 1. So a lot of different variations. But in this problem, what we are trying to achieve, we're trying to achieve the fewest number of coins that we could give. And in case where customer gave you 3 and you only have 2 in our coins array, that means like you cannot make a change, and we'll be giving just -1. So this is a dynamic programming type of problem. So first, let's jump into coding. Prior to that, like, let's actually try to define the transition function. So our objective function, what is our objective in here? So we are trying to give the fewest number possible. And let's take an example from this one. Let's come up with some base cases. So if we have denominations of 1 and 2 and 5, so if customer gives us 0 cents, what will be the amount of coins that we'll be giving? We'll be giving 0. If customer gave us 1 cent, how many coins we will be giving? We'll be just giving 1 cent and 1 coin, so we'll be giving 1 cent back. And if customer gave us 2 cents, we could give 2 cents right away, so we will give 1 coin with 2 cents in there. And customer gave us 3, so how many coins, the fewest number of coins that we will give? So we could give 2 and plus 1, which will make up 3, so 2 coins, which is 1 plus 2, and it goes on and on. So from here, so we could come up with our transition function. So let's say for I, we could see that our goal is try to find the minimum, so fewest number, and from here, so from our amount, we will be giving out that cent denomination. So in case when it was 1, we are giving out -1, and in case of 2 cents, we will be giving out 2 cents. In case of 3, we'll be giving out 3 cents. So basically, we're giving out a coin amount in here, and when we give out that coin amount, we are giving 1 coin count. So the count of the coin will be 1 in here. So you can just put 1. So this is our transition function. So from here, so we could see that this is a bottom-up dynamic programming. The reason is that we are relying on previously calculated solutions. So, and our solution is in this f of I. So we'll be returning fy. So the biggest part in dynamic programming is just to try to come up with a transition function. Once we have it, the coding part should be straightforward. So let's look at just a denomination. So this is a coin denomination that we have in our coins. So let's jump into coding up now. So we could just assign the name, and this is amount plus 1. So we are creating a DP array and allocating size of amount plus 1, because array starts with 0 index, and we are giving also a space for the amount. So our indexes will be the amounts. So when we are interested in amount, so when we are giving amount to our DP array, it should return us the answer, because like this will be the final answer in here. So we are allocating amount space for amount basically. And what could also we do is just like fill out all this values in our DP with the maximum number. I mean, it could be any number that is greater than amount. The reason why we are doing it is that there could be cases where there is no change for given amount, and so that means like when we are returning our final result, if there was no type of change and it was a amount that was greater than which it was this one right here, so like greater than amount, then that means like there was no change, so we will be returning -1. If it was less than this number, that means like we have updated our DP, and that's the answer that we'll be having. So what was our base case? So for 0 cent we were returning 0 coins. Now let's go over iterating. We could start with one amount, 1 cent, because like we took care of when there is 0 cent. So we are going inclusive with our amount. Now we'll be just trying to come up with this transition function in our code. So we could say that for coin denomination, for each coin denomination, we were calculating this. So we could go over our coins array as well. So now we have an access to our coin denomination. So we could create our transition function. And prior creating our transition function, we need to filter out instances when our amount is let me just put it in here. So coins, so when we are accessing our denomination in here, let's say if it is smaller or equals to our amount, then we are calculating our updating our DP. So let's say it's like if coin denomination was bigger than our amount, then there is no need to update our DP, because like there is no change for that. We cannot change that amount. So only time when given denomination is smaller or equals to amount, then we will be updating our DP. So now we'll put our transition function in here. We'll get so it was right here, negative minus, so coin denomination, we can access it from coins, and that's our J, and then in the end we are adding the amount of coin. So yeah, so this is our final answer. Our final answer will be holding up here, but we need to also check if there was any type of change in here, because we are filtering out, and in cases when given like examples like this amount was larger than 2, then for our DP's last index we won't be updating it for that amount, and it will be larger than that. So what I mean that when we are checking, so DP amount for, so in our DP for given amount it should hold, and the least the minimum number of coins, because like we are updating it here. However, if it doesn't, in this condition, if it gets filtered out, that means like we didn't even get a chance to update it, because like the given denomination was greater than the given amount, so we were not proceeding. So we are comparing with amount. So if this amount is larger than amount, that means there was no update and there is no change, so we're returning -1. If there was, then we'll be returning the count of coins. So let's run our code. Let's submit it. Yeah, so for time complexity, we have this O of n, where n is all those numbers in amount. Then we have O of m, which is all those denominations in our coins. So overall time complexity is O n times m. And as far as for space complexity, we are using extra space and this dp in here, and so this is O of n, where n is all those amounts in this dp.